Welcome to this explainer. Today, we're bringing you a sharp, no-nonsense masterclass on building an absolutely bulletproof case for the Cambridge AS and A-Level Computer Science 9618 exam. I am so excited to guide you through this, because we're tackling one of the most notoriously tricky areas of the entire syllabus, producing abstract models of systems. But here's the secret. We aren't just going to stare at code or data structures today. Nope, we're going to completely rewire how you approach this exam. I want you to start thinking less like a stressed-out student trying to memorize a textbook and way more like a top-tier barrister preparing for the biggest legal case of their career. Think about it. In a courtroom, a barrister doesn't just throw a bunch of random facts at a judge and hope for a win, right? They build a structured, undeniable narrative. They present evidence, they construct a logical argument, and they arrive at a flawless conclusion. And that is exactly what you need to do when you sit down to tackle these complex, abstract modeling problems. We're going to use the exact source material and data provided by Cambridge Principal Examiner reports to break down the mechanics of a perfect answer. Get ready to totally transform your exam strategy.
Here is our roadmap for today. First, we'll look at the challenge. Then, the core principles and strategy review. Third, the procedural framework. Fourth, the top 3 examiner warnings. And finally, evaluating your algorithm. Let's get right into it. Section 1. The challenge. Now, if you're studying for the 9618 syllabus, you probably already know that producing abstract models is not something you can just skim over or cram the night before. Mastering producing abstract models of systems is absolutely essential for your success because it appears in every examination series. Literally every single one. You can't hide from it. It is the ultimate gatekeeper to those top grades. The examiners use this specific topic to aggressively test whether you actually understand computer science or if you've just memorized some definitions. They want to see if you can take a messy, real-world problem, strip away the useless details, and build a clean, working computational model.
Okay, let's dive into this by looking at 2 classic mistakes. Take Alex's approach. Alex sees a question about abstract models, panics, and just writes down every single computer science fact they can remember. They overload the examiner with raw facts and technical jargon, but there's zero analytical depth. It's just a massive data dump. The examiner reads it and thinks, well, you know the vocabulary, but you haven't actually solved the problem. Alex's legal case is just a pile of unorganized evidence. Then we have Sam. Sam rushes the execution. They see the scenario, think they know it instantly, and dive straight into writing code. But in doing so, Sam completely misses the command word requirements. If the examiner asks to evaluate, Sam merely describes. They lose massive amounts of marks simply because they argued the wrong case in court. We need to make sure you avoid both of these fatal errors.
Section 2. Core Principles and Strategy Reveal. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the foundational theory that's going to set you apart.
The absolute bedrock of the Cambridge syllabus for this topic is conceptual understanding. This means exhibiting connected, conceptual knowledge that is highly transferable to unfamiliar contexts. That phrase right there, unfamiliar contexts, is what you need to zero in on. Cambridge examiners are almost never going to give you a scenario you've seen before. They'll throw a curveball at you, maybe modeling the traffic flow of a futuristic smart city. Superficial breadth won't save you. They want to see if your understanding of data structures and algorithms is robust enough to handle a totally brand new situation.
As you'll see, the Cambridge assessment objectives actually map perfectly onto our barrister analogy. First up, knowledge. In our legal brief, this is the evidence. Your goal is simply to identify the key elements, the variables, the data types. Second is application. This is the argument. You can't just drop evidence on the floor. You have to apply the principles directly to that unfamiliar context we just talked about. Finally, the pinnacle is analysis, or the conclusion. This is where you execute your model and verify the results. You prove, beyond a shadow of a doubt, that your abstract model solves the problem. Structure your answers this way, and you leave the examiner absolutely no choice but to award you the marks. Now, what's really interesting about this slide is how top-tier candidates actually bring that legal structure to life. They use the Peel framework. You might know this from essay subjects, but it is a massive secret weapon in computer science. Step 1. Point. State clearly what part of the system you're modeling. Step 2. Evidence. Write the specific line of code or mathematical logic that supports your point. Step 3. Explanation. Why did you choose a hash table instead of an array? Step 4. Link. Tie it all directly back to the question's specific context. Don't just say it's faster, say it's faster, which is absolutely crucial for the smart city traffic system to process vehicle data in real time. This forces the analytical depth that Alex was missing.
Section 3. The procedural framework. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the transformation phase and look at the exact procedure.
Algorithmic thinking isn't magic, guys. It's a highly systematic process, and according to the source material, there's a standardized sequence you must use: deconstruct, extract, select, execute, present. Step 1. Deconstruct the problem into manageable chunks. Step 2. Extract the relevant data points and ignore the fluff. Step 3. Select your analytical framework and data structures right then and there. Step 4. Execute with precise notation, whether that's pseudocode or a flowchart. Step 5. Present it all in the appropriate format. Follow these 5 steps and you're golden.
And here is why that process matters so much: the method mark strategy. Marks are awarded for systematic processing and clear working, even if your final conclusion is totally elusive. Think back to our barrister. Even if the judge disagrees with the final verdict, a brilliant barrister is still respected for their immaculate procedure. Examiners actually want to reward you. If you show them your step-by-step deconstruction and logical framework, you're going to scoop up method marks all along the way. If you just try to do it all in your head and write down one incorrect final answer, you get a 0. Your clear working is your safety net.
Section 4. Top 3 examiner warnings. So what actually makes an examiner reach for the red pen? Let's step into their shoes for a second. These are the top 3 fatal mistakes pulled directly from the principal examiner reports. First, confusing cause and effect. Students sometimes build a system where the logic is entirely backward, like triggering an event before the data is even validated. Second, forgetting to check boundary conditions and edge cases. An abstract model isn't just about handling normal data. What happens when the system gets a 0 or a negative number? If your model crashes on the extremes, examiners will penalize you heavily. Third, providing answers not specific to the question's context. If the question is about a hospital database and you write a generic textbook answer about binary searches without ever mentioning patient records, you lose the application marks. Context is everything.
And right alongside those warnings is this massive examiner alert. Candidates consistently confuse key terminology. In a courtroom, if a barrister uses the wrong legal term, their whole argument falls apart. It's the exact same here. If you say array when you actually mean linked list, you instantly weaken your case. The simple fix? Always define your terms clearly before using them in extended responses.
So let's do a quick challenge. Find the flaw. Imagine a candidate writes a beautifully structured paragraph explaining how a bubble sort algorithm works. The logic is flawless, but the exam question was about organizing a high-speed live feed of stock market prices. Where's the flaw? The flaw is that they never link the notoriously slow time complexity of a bubble sort to the high-speed requirement of the stock market context. They just copied a textbook page from memory. Always ask yourself, am I actually answering this specific scenario?
Section 5. Evaluating your algorithm. Building the model is only half the battle. The other half is the critical analysis.
And this brilliantly illustrates how top-tier candidates evaluate their work. The syllabus explicitly requires you to judge your own solution using these 3 metrics. First, time complexity. As your data grows from 10 items to 10 million, how fast does your model run? Second, space complexity. An algorithm might be fast, but if it eats up every gigabyte of RAM, it's useless. Third, edge cases. Testing the extreme input boundaries to ensure total system stability. Acknowledge your model's limitations and justify your decisions using these exact metrics.
To tie it all together, here is the ultimate deconstruct, solve, evaluate problem-solving framework. Identify the given information, break it down into logical steps, solve systematically to capture those vital method marks. Check for reasonableness. Ask yourself, does this actually make logical sense in the real world? And finally, make justified recommendations. This is exactly what examiners are desperately hoping to see. So here's the complete 3-rule system that guarantees top marks. Rule 1. Command word decoding. Never rush. If it says evaluate, provide pros, cons, and a conclusion. Rule 2. Peel framework application. Point, evidence, explanation, link to context. Rule 3. Time management matrix. Allocate your time based on the marks available and show your systematic working every single time.
Now, why are we pushing these strategies so hard? Because students who implement these computer science strategies see an average improvement of 2 grade boundaries, literally the difference between a C and an A, but only if they practice consistently with our weekly explainers. You have to put in the reps to make this legal brief method second nature. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Now, I want to hear from you. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.